afternoon, or good evening, or good morning, depending on where you are in the world. My name is Jeff Ballard. I am Global Director of Partner Marketing for Aerospike, and I'm here to introduce our next speaker. You know, one of the things that we've been hearing is data is growing exponentially. In fact, IDC is actually saying that data being created over the next 3 years is going to surpass all the data that's been created over the last 30 years. And that's why it's so vital for us to be able to work with leading technology providers like Western Digital. We're excited to be working with Western Digital as they really deliver some of the most advanced storage technology to help companies address that coming wave of information. We're being joined now by Mark Miquelon. He's the Director of Partner Alliances for Western Digital. He's going to be talking about getting scale without limitations, leveraging a composable, disaggregated infrastructure using NVMe over Fabric. He'll also be talking about some benchmark results that Western Digital has gotten with Aerospike. Welcome, Mark.
Thank you, Jeff. I'm Mark Miquelon from Western Digital, and I want to talk to you today about NVMe over Fabrics and some benchmarking that we've done with Aerospike and give you some motivation for looking at this solution. Our agenda today, we're going to talk about some general challenges that almost everybody is facing in our data centers. I'm going to give a very quick introduction to NVMe and NVMe over Fabrics, tell you what's good about it. And we're going to talk about disaggregating Western Digital. We've seen a lot of customers be successful with deploying disaggregated resources in their data centers. I'll get into some benchmark results that we've done using the Aerospike tool. And finally, just cover the NVMe over Fabric products from Western Digital that have enabled these fantastic results. So in our data centers today, I think everyone would agree just the volume and velocity of data is huge. And also there's a great variety of data, and we're finding new ways to value that data, new ways to mine it, new ways to use it. And all of these forces are affecting how our companies run, how our data centers are implemented, the kind of equipment that we're putting in there. There's just a huge diversity of workloads. If you look at analytics, machine learning, artificial intelligence, all of these can be, putting a pull on your data center resources in different directions. And being able to pick the right set of equipment, and particularly when that equipment is going to be used for years in advance or years to come, is very challenging. And so what composable disaggregated infrastructure does is it enables you to do more of adding equipment as you need it, not worry so much about predicting what the future is going to bring or what the future is going to drive, but break your resources into smaller, manageable chunks than a server. And then utilize those resources and change that utilization on the fly. So with an orchestration tool or even software that might be developed in-house, you can quickly set up virtual servers, use them for any period of time, might be hours, might be days, might be weeks or months. But when you're done with that workload, you can return those resources back to the pool and use them for something else. And we have customers that do this on a daily basis. They're using resources one way during the day and another way at night, for an example. And this allows a higher utilization of all these data center resources. Typically, what we see is less than 50%. So there's some survey data here that we've captured. 45% of capacity is what's used, and 45% of compute hours as well. So what does that mean? That means you're spending probably close to double what you need to in terms of data center hardware, just because you're worried about a peak usage that might come on a particular day, might come on a single day of the week, or might come on a certain part of the year for your data center. And so we're going to give you an opportunity to get rid of that and to improve that utilization through composable disaggregated infrastructure. Before I get into that, I want to talk about one of the fundamental technologies that has enabled this, and it's called NVM Express, or NVMe. This is a command set and a protocol that runs over PCI. It was specifically put together about 10 years ago by people who saw that flash memory was going to become very critical and very useful in the data center. and that the current SCSI and even serial SCSI and fiber channel interfaces for storage simply weren't good enough. The memory was so much faster than those interfaces were designed for. Those things were all designed for spinning media, that it was simply going to be a huge bottleneck. We would have this super fast non-volatile memory, but not an interface that was quick enough to really optimize it. So NVMe Express work group was formed, specifications started rolling out in 2011, and Flash and SSDs have been designed and developed and brought to market around these specifications ever since. The huge improvement that we see with NVMe over other storage protocols is most notably in the latency. And latency really affects real-time decisions and database access. And so with NVMe Express, you're able to get very low latency and very consistent latency in and out of these SSDs. So when you're doing searches, reads and writes, your performance is very consistent, much more so than with SATA or SAS or fiber channel over a SAN. The limitation that NVMe Express had and these NVMe SSDs have is how many can you fit in a server? And the original servers came out and they supported 2 or maybe 4 of the SSD slots, could be NVMe. Now we're getting to the point where it's more ubiquitous. You're seeing 2U servers with 24 NVMe slots, pretty common. There are some that are higher. Form factors are changing to allow everything, but you're still limited to sort of that range. You're limited to tens, maybe 20 or 40 max NVMe Express SSDs that you can get in a single server, and so that limits the size of your data, which may be fine for some people, but not for everyone. And this has been recognized across the industry, and so the idea of mapping NVMe over fabrics has also been standardized. This was first done or the first standard came out in 2016. It's now starting to be deployed by Western Digital and by others. And it's pretty simple. What we do is we say, take that same NVMe command set, get access to those same very low latency SSDs, but be able to scale that over a fabric. And NVMe OF doesn't even specify the fabric. It says, hey, any suitable fabric can do this. And implementations are out there today for fiber channel and also for Ethernet. The Western Digital products I'm going to talk about today are all based on Ethernet and specifically 50 and 100 gigabit Ethernet ports. So with the addition of NVMe over fabrics, now we get the same great performance, same low latency, but we can scale that to a much greater degree and put it on a fabric. And that lets us grow the storage set or the size of the data set, but also lets us access that same data over a larger number of servers, just like any good storage fabric would do. Okay, so that's just some background on NVMe and NVMe over fabric that enable what we're going to talk about. Now I want to talk about what is composable disaggregated infrastructure. On the left-hand side of this picture, you see a representation of a pretty standard server used by all of us in the industry today. You have a CPU with direct attached memory, and then across the PCI bus, you have definitely an Ethernet NIC. You may have flash, you may have disk, you may have GPUs and FPGAs and other types of accelerators in this machine, or you may not. But all of those are typically housed inside a server chassis, which I've drawn a blue box around all those resources to identify that. If you can run your application and keep all your data inside that blue box, life is good. But once you need more servers, more CPUs to access the same data, or if your data set gets bigger than what you can store inside that server, now you get into a scaling problem and you have to decide, am I going to cluster servers? Am I going to go with a SAN or something to grow my storage? There's a lot of options, a lot of ways to do it. A lot of us are doing it, but it gets complicated. On the right-hand side, we show a simpler version that we call scaling by adding devices, and this is disaggregated infrastructure. So we've disaggregated each of these hardware components into a separate piece of sheet metal. And we've provided an interconnect. Now, the interconnect could be PCI, but to get a larger scale, we recommend Ethernet. And again, remember I said NVMe over Fabrics does run on Ethernet. So that's kind of the built-in feature that we all enjoy coming from that NVM Express workgroup. So once you've done this, you're able to scale if you need more compute, just add more compute. It probably comes with memory. Even though we've put memory in the disaggregated portion of this architecture, today, most CPUs need memory directly attached. And for the foreseeable future, that'll be the case. If you need flash, add flash. If you need disk, add disk. If you want any accelerators, those can also be attached over the Ethernet fabric. And so the key to this is that we've kind of changed from a local PCI bus that really is intended to run within one cabinet or one piece of sheet metal. Yes, you can extend it beyond that, but that gets complicated as well, to something like Ethernet that has great scale. And you can add these devices in multiple racks if you need to, and scale this without limitation, essentially. So what have we done with this? Now I want to get into the actual performance results. And we've used Aerospike certification tool to run on a product that I'll show you in a little bit called the OpenFlex E3000. Think of the F3200 as just a bunch of SSDs available over Ethernet, okay? And we've put together this cluster that you see on the left. It had 3 clients, a couple of application servers that were actually running the Aerospike database and the certification tool. And then those we sort of created a second network here for the storage. So the blue lines between the network switch and the application servers right there in the middle, and then the yellow lines going all the way down to the OpenFlex box. Those are all an RDMA network. We've used Rocky to get optimal performance in this case. And we went ahead and ran the Aerospike certification tool. I'll show you those results in a minute. On the right, we say, what would this look like if you wanted to scale it? So this is a pretty small scale proof of concept that we did, and just wanted to collect some performance data to share. But if you wanted to grow that, you would simply replicate that, and we're showing it, one rack at a time, but you could share racks. There's no reason that it has to be this way. This is just one way we wanted to show that it could be done. So if you think of everything on the left-hand side as being one rack, and then you can step that to be as many racks as you need or you'd like. Okay. Now I want to get into the results. So we've run this Aerospike certification tool. There's 2 tests that are critical that I'm showing results for. And if you look at the chart in the upper left, the blue line, this is tracking transactions per second. And we get up to over 850,000 transactions per second in this certification test. The box to the right shows a green line and a yellow line. These are simply breaking out the reads and the writes. So there's various workloads as you go across the x-axis, certain percent of reads and certain percent of writes. And you can see that in more detail on the right-hand side. So reads are the yellow line, green are writes, and if you add the yellow and the green together, you should get the same number that's in the blue line. What I want to say about these performance results is they're kind of staggering. So Aerospike collects performance from various implementations, people who have run this tool on their website. I've got a link to it that's in the slides here. You can go check that out yourself. These results are more than double. And significantly more than double anybody else that's run this test. And the reason for this, it has to do with the amount of flash and the availability of the flash through the 100 gigabit Ethernet network. That I'll show you more details on that product coming up in a second. The chart at the bottom talks about latency. And I say that it's consistently low latency. The line here may not look like that. So you may be looking at, yeah, the yellow looks kind of consistent, but the blue's kind of all over the place. What I want to say is the scale of this. We've really zoomed in on it so you can see that there is a little bit of deviation. The typical compare point in the certification tool is at things that finish within 1 millisecond and then 4 milliseconds. we're looking at the highest thing on this chart. So the peak in the blue line there is actually at 200 microseconds. So we're about an order of magnitude below what the certification tool would typically even register and measure. Okay, all this data is on relatively small records. So there's 1 million keys. They are each only 50 characters in size. And then the second run of the certification tool is on bigger records. So these are on 1,000-byte records. You see pretty consistent performance. So we're still above 800,000 transactions per second. They're a little bit less, but not even really too much less. And you see pretty consistent breakout of read versus write on the right-hand, upper right-hand chart. And again, the latency here looks a little bit inconsistent, but again, the highest peak here on this chart is 120 microseconds. And again, we're in this tool, the lowest threshold, the lowest thing that we typically look for is under 1 millisecond. So again, we're about an order of magnitude lower in latency than any excursion that we would typically care about. So we've run this test and collected this data in conjunction with Aerospike. We have a paper on it at our website. Aerospike has posted the testing, and they have a similar paper on their website, and those links are available. Okay, now I want to do the available on Western Digital, just so you know what we have. This OpenFlex Data 24. It looks very typical. So it is a 2U chassis, 24 NVMe SSDs. Each of them are hot swappable, available at the front of the chassis. It ships with our latest SSD from Western Digital, the SN840. Very high performance, dual port. This box is all what we call highly available. So if I were to show you the back of this box, there's an A side and a B side. They each have independent power supplies, and they each have 3 ports to the Ethernet fabric. And our implementation or our connection to the Ethernet fabric is made through another product that we have inside Western Digital, which is called our OpenFlex C1000. This is a 100 gigabit Ethernet adapter that is very specific and highly optimized around NVMe and NVMe over fabric translations. So this box, again, allows you from a redundant fabric connect, an A side and a B side, to get to any of the 24 SSDs in the chassis. You can stripe data across those and RAID them however you like. All that is done external to the box and done via software. Okay, the box that we actually collected this performance data on is called the OpenFlex E3000. It's the thing on the far right here. And the E3000 is actually just a chassis, and it holds up to 10 of these F3200 fabric devices. The F3200 is available in a large range of capacities, all the way down. It starts at 12 terabytes and goes all the way up to 61 terabytes per device. So you can get 610, actually 614 terabytes in this OpenFlex E3000 chassis. So huge amount of density here in terms of how much storage you can get in a small amount of space. We use a different Ethernet controller in this case. We use a Broadcom Stingray, and that Broadcom device abstracts the individual SSDs that are in the F3200 from the fabric port. So when you're looking into this device from the fabric side, you see a single NVMe namespace. You can go into that. You can break it into as many namespaces as you want. But and you don't really address directly the individual SSDs behind it. That's all abstracted to you behind the Stingray controller and our firmware. Okay, and with that, I'd say thank you for the time, and we'll take some questions.
Thank you, Mark. That was a great presentation. Always interesting to see what you guys at Western Digital are doing. But I did want to add a little side note. If you can work with that NVMe organization, I think that's probably the hardest acronym I've heard of. It's actually easier for me to say non-volatile memory express. So if you could work on that, I'd appreciate it.
It just rolls right off the tongue, NVMe, but you know.
Yeah, I had to look it up, and when I saw it written, it's like, oh, okay, now I have the acronym. Well, we do have some questions, so I want to get to those. One of them that came in, I see the question is, does Western Digital have a tool that can help manage the life cycle of these new drives, since they have a defined shelf life? In real-time, high-speed data world, it's important to be able to predict failures.
So short answer is yes, we do, and I'll get to that in a second. I also want to just touch up on a defined shelf life. So when you're shopping for SSDs in enterprise space, you'll see a thing called drive writes per day, or DWPD, and it's sort of a category more than it is a specification. And so what I mean by that is you'll see a 1, or now everybody's kind of moving to a fraction of 1. So Western Digital has 0.8 drive writes per day. And really what we're talking about is just how many times you can fill the SSD with data before it begins to wear out, or essentially before you burn through your warranty. And rather than talk about really huge numbers of writes, because that ends up being billions of writes kind of thing, we've broken it down into the number of days of the warranty, which for our drives is 5 years. Some companies might be 3 years. And then the number of times you could fill that whole drive for that period and still be in your warranty. Now, it doesn't mean that there's a shelf life. We're just speaking to the warranty of the drive. If something goes wrong, you can return it and get a new one within that time. Okay, and that number competitively is actually moving in an odd direction. So it's moving from high to low. Years ago, we had 10 drive write per day class of devices, and 5 drive write, and 3 and 1. Now we're pretty much down to somewhere in the 2 to 3 range, and somewhere less than 1 are really the categories of enterprise SSDs that you're going to see out there. 2 things are driving that. One is, people don't write as much data as they think. And the other thing is that the devices are getting bigger. So everybody's buying in excess of 1 terabyte. There's 15, and people on their roadmaps have 32 terabyte SSDs. Well, as that capacity grows, your ability to write that much data in a day goes down. So the drive write per day category kind of tracks with that. So that's the long answer. And yes, Western Digital has a drive manager tool. It's available on our website. We've just gone through some rebranding. As if you followed Western Digital for a long time, there's been some acquisitions, SanDisk and HGST and everything. So everything has just been rebranded Western Digital. And I may not have the most current name for this tool, but it used to be known as HGST Device Manager.
So that's great to know for sure. So another question that's come in is, can it work in my existing environment, or do I need to revamp/refresh?
Yeah, so the composable infrastructure that I discussed can work with your existing equipment. And this is a common question. We talk about disaggregating the storage from all the other resources, which optimizes your use and your flexibility when you scale. But you can start with servers you have today, and that's actually what most people do. So the compute and memory, and even some of the storage, are typically in a server. Same with the accelerators. GPUs and FPGAs are going to be in a server. We are starting to see the emergence of servers that really don't have any of that stuff. They truly are just a compute and memory device. Those are being created actually for computing on the edge, but they're applicable everywhere. But most definitely, everyone starts with what they have and then sort of gets more specific about it as you go.
Now, how does NVMe, there's that acronym again, track with the PCI generations, Gen 3, Gen 4, Gen 5, et cetera?
Yeah, even though NVMe is inherently based on the PCI interface, they are completely disaggregated, I'll say, in terms of specification. So PCI generations tend to double in speed. And so that's the primary reason that you see, Gen 3, Gen 4, Gen 5, there's a doubling of data bandwidth on each generation. Whereas the NVMe is really a command set that runs across those lanes and could care less what speed you're running at. You can go backwards and run it on the original PCI. And that's actually, you know, NVMe is used all the way from the high-end enterprise stuff down into our laptops. So if you have a new laptop with an SSD in it, it probably has an NVMe interface. It's probably a slower one. You know, 1 or 2 lanes of Gen 2 or Gen 3 is just fine for a laptop. So they're completely separated.
Makes sense. Now you talked about the OpenCDI. Does that have to run on Ethernet fabric, or are there other options available for that?
Yeah, there are options. So NVMe, when they defined NVMe over fabrics, did not specify a fabric. Okay, and they specified some criteria that make a fabric worthy of being used in the enterprise, but there's a lot of fabrics that do that. So you can get NVMe over fabric running on Fiber Channel, running on InfiniBand. We chose Ethernet because we think it has the best roadmap. And what I mean by that is there's just lots and lots and lots of Ethernet ports in the world, which means there's lots of switches, there's lots of NICs, there's lots of competition, which drives the price down. It also is faster. So if you just compare raw speeds of what you can buy today and what's coming in, say, the next 3 years, Ethernet is actually better than Fiber Channel and better than InfiniBand.
That's great. Looking to see, yeah, so we've got one more question here. So beyond the storage resources offered by WD, who else is bringing hardware resources for CDI to market?
Yeah, I spoke already about the compute resource. Those are actually available from WeWin and from Nokia, at least. They're my mobile. Those are the 2 I know of that have that compute node that really has nothing else in it besides a place for an Ethernet NIC and a compute memory. We're actually doing some proof of concept work with both NVIDIA and Xilinx on the accelerator front. So we have NVIDIA GPUs and Xilinx FPGAs that are not productized right now, but in proof of concept in this disaggregated format. And we're also inviting other storage vendors to participate as well. Right now, I think Western Digital is really the only one that has storage products in this category, but we invite competition, and we'd like to see that. We know our customers would like to see that too, actually.
Well, that's great that you're certainly supporting those open standards, because that's a very important aspect for sure. It looks like that is about checking all my monitors and screens here. It looks like that's the end of our questions. If anybody has any, certainly feel free to add them into the chat. But if I don't see one, thank you very much, Mark, for participating. Love having you guys here at the event. It was a great presentation. And by the way, thank you for your sponsorship, the Western Digital sponsorship of the summit. So if you want to have some more conversations around NVMe and the CDI, OpenCDI, see, that's a much easier acronym, OpenCDI. I can do that. If you want to have conversations around any of those, stop by the Western Digital booth. They'll be here for the next few hours. And the team there can certainly answer and address some of your questions. And it looks like, yeah, that's it.
All our marketing people that you love OpenCDI, they'll be thrilled. So.
Yes, it's easier to say. That's my thing. It's just easier to say. So thank you very much, Mark. Appreciate you coming on. And as I said, please stop by the Western Digital booth to get some more information. Thanks.
Thanks for having me.